session shortly. So, till the participants join in, could you quickly confirm if I'm audible? You can type a yes in the chat box. Thanks everyone for confirming. Just couple more minutes and we'll start today's session. Good evening and a very warm welcome to today's exciting and insightful webinar, which is Prompt Engineering from Foundational Concepts to Advanced Applications. So, we are delighted to have you join us for this engaging session designed exclusively for professionals and leaders eager to harness the true potential of this generative AI. So, in this webinar, we will demystify the art and science of prompt engineering, the critical skill that bridges human intelligence and AI capability. And you will discover how well crafted prompts can, dramatically enhance AI outputs, improve decision making, and streamline business communication. By the end of this session, you'll gain practical insights into how prompt engineering is reshaping the way leaders think, create, and execute in the age of AI. And to lead us through this fascinating journey, we have with us today our esteemed speaker, Mr. Sham Venkatesh. Mr. Sham is the Director of Architecture in the FinTech industry and a seasoned technology leader with over 20 plus years of experience. His expertise spans across various domains: data science, cloud architecture, AI/ML, and automation consulting. He's also highly skilled in Java, full stack engineering, microservices, and many more, and has also led high performing teams in delivering scalable and robust applications on the cloud. So, today we have with us Mr. Sham, and he will be sharing valuable insights on the foundations of prompt engineering. And we'll also have an interactive Q&A session at the end. So, feel free to post your questions in the chat box. And before we begin, a quick note on how this session will flow. To ensure we make most of our time, attendees are in listen only mode. However, you can send in your questions via the chat. Okay. And today's session is just the beginning. If you're looking to deepen your knowledge and skills, we encourage you to explore our PGP, postgraduate program in AIFL, Artificial Intelligence for Leaders. It's a 5-month intensive course designed specifically for business leaders who wants to leverage AI for, strategic decision making and also transformational leadership. So without further ado, let's dive in. Over to you, Sham.
Thank you, Lakshana. Hello, everyone. Good evening. So let me share my screen. We'll go through the discussion around prompt engineering. So please confirm if you are able to see my screen in presentation mode. All right. Thank you. And I believe, with that confirmation, I'm also audible, right? Otherwise, please let me know. Right. So let's begin, and again, welcome to all of you. Right. So this next 50 minutes, we will focus on prompt engineering. Right. By the end of the session, I hope you as leaders will be able to take away what are the different techniques of prompt engineering, why prompt engineering is important, and how do we look at prompt engineering at scale, right? How do you, it's not just an associate or a leader sitting and prompting and getting the most of the LLM, but how do you scale this, right, across the enterprise? How do you scale it for huge volumes, right? So let's try to understand that. And by the end of the session, I hope I would have been able to um, uh, draw this, learnings over to you, right? So again, I know Lakshana said, we'll have Q&A towards the end, but I feel the question should be asked right when you have it. So don't have to wait till the end. Put your questions on the chat. We'll try to take it up as we go, right? It need not wait till the end is the whole point. So let's begin on prompt engineering, right? So, folks, Gen AI has moved from a novelty, right? What used to be novelty, only few people had access. It's almost a necessity now in enterprises, right? So we see associates using GitHub Copilot, extensively. We've seen, Copilot being used, right? And most of the performance cycle comments and leave applications are all today generated by LLMs, either chat gpts or claude or perplexity or one of that, right? So it's become almost ubiquitous these days, right? But the power of the large language model, right, while it's the same tool, you can get different outcomes, right? And the differentiator here is how you communicate with it, right? So these prompts that you give are strategic instructions, right? These are not casual queries, right? So that's the whole point. So what we're saying is, you can advance from as basic as summarizing a text to an advanced prompt, right, using certain techniques, right? And at the same time, while you are using the technique, you are aware of the underlying technology, or aware of how this technique is being leveraged to maximize the or optimize the outcome, right? So that's something I want to make sure everyone understands, right? So the definition of it, is that prompt engineering is an art, is an science, right? And it's basically to communicate effectively with AI systems, right? And we train employees in our organizations the same way. With the right instructions, we can now guide AI, not with code, but with carefully crafted prompts. And this will help AI direct towards useful output, accurate output, and more context aware output, right? So for leaders such as yourself, this isn't a technical curiosity, it's a core capability. Whether you're generating a report, whether you're analyzing data, whether you're drafting communications, you're summarizing some document, how you frame your question will determine the quality of AI answer. So prompt engineering, we've been hearing that engineering is all about coding, but prompt engineering is less about coding, but more about problem framing, all about context control. And sometimes it's iteration, it's iterative. It's exactly how you leaders think, and you're already great at that. So mastering this skill will empower your team and yourself to unlock some real potential, some real productivity, and make your decisions faster. And we believe it will help you innovate at scale, right? And at the same time, you'll be doing it ethically and responsibly. So why it matters? Because it will enhance the quality, you know, and the relevance of the generated content. It'll improve your performance across various AI tasks. We will look at some examples of this as we go. It will make the AI more context aware. The interactions are much more context aware. It will maximize the potential of large language model. Right. Now we look at what makes a good prompt. But before we move there, I want to take a step back. Right. I want to take a step back and I want to ask everyone here, what are you prompting against? Right. So you have a system here, right? And what we are saying is, a person is trying to prompt to the system, and the expectation is that there is some output, right? So what are we prompting to, right? So what is the system? Can anyone tell? You can put it on the chat. Uh, you can put it on chat, Srinivas. This. Yeah. Purvika says chatbot, right? Prakash says, it could be an LLM, right? What else? Yeah, LLM. Great, great. Yeah, so basically, this is a large language model, right? Now you can build applications on top of it, and that can become a chatbot, right? Or that can become another interface, right? Where you're actually instructing the large language model, right? So Srinivas says prompting means telling computer what we want, right? So in this case, the AI we are referring to is a large language model, right? And why do we call this large in the large language model, right? The large here refers to the amount of parameters, right? It has millions or billions of parameters. What I mean by that? So you know about supervised learning and unsupervised learning, right? So supervised learning is where you have data with labels. Unsupervised learning is where you don't have any labels, and we are expecting that the machine will help us come up with labels using pattern recognition, using using basically categorizing your data sets, right? So what we are doing is we are taking these data, both supervised learning, unsupervised learning, and using various techniques, right? Like reinforcement learning, semi-supervised learning, unsupervised learning, various techniques. We are training the AI model, right? So this is our AI model, right? So we are training, and when we do that, we are training with almost the entire web data, right? We are training with millions of ebooks. We are training with whole lot of Wikipedia pages, right? And all those different data that makes it on billions of parameters, right? I don't know about the latest Chat GPT, but the Chat GPT 3.5 had 755 billion parameters, right? So that's the and for context, uh, an average human brain can only perceive or only throughout the lifetime would have been trained for 2 billion parameters, right? So that's the scale, right? So you can imagine 755 versus 2 billion, right? So it is equivalent to many, many humans, right? Or many, or and much more effective than that, right? So that's why we call it as large language model, right? Now, what is this large language model under the hood, right? So let's talk about that. So when we when we actually give a prompt to a large language model, what exactly is happening, right? So what do you think is happening, folks, when you give a prompt to a large language model? What exactly is happening? All right. So let's look at that, right? So let's say I prompt something like the cat sat on a dash, right? This is the this is the uh, you know um, this is the prompt I'm giving to a large language model, right? So what's happening is when I give this kind of a sentence, right? So the LLM, before it does any kind of yeah, Prakash, it's basically running algorithm. And I will tell you what are those algorithms, right? The first step that happens is something called tokenization, right? Now, for different type of models, there are different pre-trained tokenizers, right? But the jargons aside, to make it simple for all of you, right? So tokenization is where we take this entire sentence and break it down into subwords, right? What we also called as subword tokenization, right? So probably the tokenizer might split this as D into one of the token, cat as one of the token, sat as one of the token, on as one of a token, A as one of the token, right? And some tokenizers behave differently, but for simplicity, let's take that it has tokenized based on the word. Okay. The next step is called embeddings, right? So there will be a model which does tokenization here, tokenizer model as we call it. There'll be a model that does embeddings, right? So we call it the embedding model. So what do I mean by embedding, right? What does this embedding model do? This embedding model will come up with vectors, right? Now, as you all know, machines, computers, the algorithms that you have been talking about can only deal with numbers, right? So they can only deal with numbers. So embeddings convert these tokens into vectors which are numerical, right? So these are numerical vectors. And what these vector contains, they contain semantics, right? What do I mean by semantics? Semantics is the relation between the sentence, between the words, between the tokens, the relation, the context. Here I'm talking about the cat, right? Now cat could also have been referred to, the exam cat, right? And many other different things, right? But in this case, the machine knows by the context, because somebody is sitting, it has to be a living thing. And in this case, it's an animal cat, right? And it is sitting on something, right? What is the most probable thing that it can sit on, right? So that's what it will try to calculate, right? So embeddings is the semantics. It's come up with semantics of the tokens, right? And the next is what we call as a transformer model, right? So this is the heart of all the large language models, right? Transformer model. Now, what's a transformer model? In 2012, right? Until 2012, we didn't have a transformer model. This transformer model was the state of art. It kind of transformed our AI industry, right? Google open sourced this, and they came up with a research paper called "Attention is All You Need," right? And I would encourage all of you to read this research paper. It's not at all technical, right? It's very very generic, something that you can read. It's a 12-page research paper. Attention is all you need, right? So they came up with how you can do natural language processing task using models such as transformers, right? So in this transformer model, they have something called self attention, right? Where the model will give attention to some of the most useful tokens in a sequence, right? So if this is a sequence, it'll look at most useful tokens, right? So that's called self attention. And it will also have semantics, it will also have context, right? Are we talking about past tense? Are we talking about something that happened historically? Or are we talking about future tense? Or are we talking about simple present tense, right? So it will try to get all those things. It will try to do what are the names, what are the entities, what it will try to recognize them. It will try to come up with what are the nouns, and what are the pronouns used, right? What verbs are used, everything, right? All that is part of the self attention context, right? Along with that, there is something called decoder, right? And decoder again has at the end of this called probability layer, right? So this probability layer, what it does is it applies a technique called softmax, right? And again, don't have to worry about all this technicality. So what this does, and what you need to know about this, is that it comes with a final token probability, right? In this case, it will say, it will come up with a list of tokens, right? And the probabilities against them. Like, for example, the cat sat on a table could be like a 92% probability. The cat sat on a chair would be like 90% probability, right? The cats sat on a sofa could be 77% accuracy, and so on, right? So typically, this is the probability distribution that the transformer is giving you, the output layer of transformer is giving, right? Now here, the model is trained to do a sampling of this, right? In a typical case, whatever is the most probable is what it will give back, right? And in this case, it might say the cat sat on a table, right? Now you can also play around this with things like temperature, with top P, with top K, and different configurations to make this more creative, right? So you can make this the output of LLM more creative by configuring that way. But typically, it would go after the most probable token out of the distribution, right? And if you see all these tokens, they don't add up to 100%, right? Each have its own probabilities, and that's why we use the process of sampling, right, to get that, right? So this is what is happening under the hood in a large language model, right? And the entire job of large language model is to predict the next token, right? So the only job of large language model is to predict the next token, right? So you have an input prompt, right? And this is the output, which is basically a next token, right? And even if you look at, I'm sure you would have noticed this, even if you go to like ChatGPT, right? And you say, right, give me the summary of um, Odyssey, uh, Odysseys, or let's say um, uh, summary of um, Roman civilization, right? Something like that. And you will see what it's typically doing is coming with token by token, right? It is doing just the next word prediction, right? All it does is next word prediction. And there is a comprehensive model which makes sure that the next word, next token is more grammatically correct, it is as per the context, right? And it is kind of aligned to the system prompt and the user prompt, right? So that's typically the job of large language model, right? Now these input prompts, right? So what we are trying to say is these input prompts can need not be very random, right? It need not be very ad hoc, but it can be meaningful. It can be more fine tuned so that you get a good output, right? So we are telling the a good prompt should have instruction quality, right? It should tell the model what to do very clearly, right? So we don't want the model to be guessing and give you multiple or random outcome, and then you will have to iterate, and you might be kind of deviating or digressing from the actual context, right? And then supply as much relevant information as possible, right? Some context, some background, right? So like I'm trying to teach a 8-year-old, right, on the Roman civilization, right? And this 8-year-old has no background, no knowledge on any of this, right? And then these are some of the context I can give, right? So this way, the LLM can make sure that it's able to craft the outcome in a way that the 8-year-old can digest it, and provide as many constraints and formatting requirements. You can say that you want it in bullet points, you want it in 150 words. You can say give me as detailed information as possible, right? And you can also give some examples. Here's an example of how we thought the 8-year-old about the Indus Valley civilization, and we taught them where exactly in the geographically, where exactly it's located, and then we talked about how. Historically, how back we go, and how did we get to know about these civilizations, and more details about the actual civilization and how long it lasted. Right now, we talk about Roman civilization. We'll try to follow this few short example. We'll talk about different prompting techniques. One of the technique is few shot prompting, right? So we will talk about that. So what we are telling is a good prompt can also include examples and try to say what is the persona or role the LLM has to play. Now, I talked about LLM, right? And I talked about how it is trained with 700 and plus billion parameters, the ChatGPT 3.5, right? Now, what I want to say is when we trained the model with all these billions of parameters, they were all general training, right? These are all general training. They are not very specific to, let's say, a history research. They're not specific to pharmacy. They're not specific to cardiology. They're not specific to robotics, right? So it's not domain specific. These are very general data, general knowledge data. So domain specific knowledge is missing when it comes to large language model. But it is trained on generally on all the domains across the world. So if you can carefully prompt, you might be able to even, kind of squeeze through and get the domain specific info from the large language model. And that's the whole purpose of prompts, right? So we are trying to get domain specific. Now there are various ways, folks, right, to get this domain specific outcome from a large language model. Let's say you're using large language model to be able to I'm just making this up, to be able to do a customer support. Okay, you're doing customer support. Let's say you are from a financial services company. Okay, and you deal with high net worth customer, and you have to give white glove kind of service to your customer, right? And you're using large language model as a customer support bot to support this kind of customers. Now, the LLM as such, it knows how to do customer support. It knows about financial. It knows what are high net worth. It knows how to give a white glove service, right? But it will only do as long as you are able to prompt that, accordingly. So by prompting that, it's able to do that, right? So what we're saying is, when you can basically convert your large language model to be repurposed as a customer support bot, right? Now, one way of doing that is by good prompts, and there are other different ways of doing that. You can also do that using something called SFT, right? Supervised fine tuning, as we call it. And there are various architecture to do that. There, one of the very popular architecture is called RAG, right? Retrieval augmented generation. Here you can actually integrate large language model to a domain knowledge source, right? It could be your customer, your customer database. It could be about, all the previous interactions the customer had with a real customer support agent, right? And the LLM can look at it and use that as a reference to, respond back to the customer. Now, these way of fine tuning, the supervised fine tuning techniques are very expensive, right? So you'll have to architect it well. You need development effort. You need machine learning engineers. You need data scientists. You need ML ops, and then you will be able to achieve that, right? And versus the other technique, which is prompting, is the most inexpensive approach. It is very cost effective. It is very easy. It is far, far simpler than you have to build a, RAG kind of an architecture. So the whole point we're trailing is, there are techniques available out there, right? But your first approach should be good prompt. With that, you'll be able to fine tune your large language model output to any of these use cases, be it customer support, be it insurance, insurance, let's say, processing bot. It could be, you're building some low code, tools. So all these are use cases, and your first approach, which is the most inexpensive, most cost effective, and the most simplest approach, is prompting, right? So that's what I wanted to reiterate. Yes, you will have to give the persona, and with that, it makes gives much more context to the large language model as to what role or what persona it should be playing. It can talk to an 80-year-old as a very intellectual person, and it makes no sense for the 8-year-old. So you can say that as a tutor for an 8-year-old, or as a guardian of an 8-year-old. Can you tell me, about Roman civilization? And this is how, the 8-year-old learned about Indus Valley civilization. And can you, package this output in 10 bullet points, right? Or give me as much details along with, reference images of this Roman civilization, right? So things like that. So that will become a good prompt. Now we'll talk about different types of prompt, right? Or different techniques of prompt, right? And one such technique is called zero shot prompting. Now, zero shot prompting is very simple. It's a direct ask. You just give an instruction which is quick and it is generic. You're telling an example here says, classify this text, and AI model will give a response which is most case generic enough, right? Or neutral enough. An example could be, write an ad for a smartwatch. So this prompt, you're using in marketing, imagine, right? And it's boring. It's a one size fit all kind of a prompt, right? So zero shot prompting can be, very direct, and in most cases you may not, the output will be very generic, right? But with more, newer models, right? Yeah, all the models after GPT 3.5, GPT 4.0, and all those 4.2, 4.3, etc., right? So they are very powerful, right? They're very adaptable, and they have something called auto prompting. So many times even zero shot prompting should suffice, right? But why leave the mercy to the training of the model, right? Why you're actually trying to ask the model to perform a task without giving any examples? It's just an instruction. It's just a question. You're telling, translate the following sentence to French. You're not giving any previous translations. You are just telling, giving a sentence and translate this. Now this works. Where would it work? It would work for, when you're from a diverse domain, right? So you want LLM to perform, wide range of tasks, right? Very wide, like translation, like summarization. These are wide range. It's not domain specific. It's not very task specific. So zero shot is very good at for those cases. You don't need any task specific data. You don't need any label data. You don't need any fine tuning. You can, uh, you know, um, even the language and context are flexible, right? When it comes to zero shot prompting. And zero shot prompting, you can, serve multiple teams. Marketing can go and talk about support. Support can go and talk about HR, right? Prompt about HR and things like that. So it's a plug and play kind of thing where you're only expecting the model to do general specific, or no task specific, wide range of task, right? But let's say you want to do industry specific, healthcare, legal, education, software development, marketing. So those case, you know, zero shot prompting may not suffice. Okay. So what you need probably is a few shot prompting. In this, we typically, give the prompt, give the LLM a prompt, um, and along with few examples. And then we expect the model to understand the task better. And this way, the performance or the nuanced task that you're asking the model to perform is able to be done. So you're basically giving better guidance for specific task, right? In the previous case, zero shot prompting is usually for wide range of tasks. But for a specific task, the recommended way of doing is fused shot prompting. And the outcome, accuracy is improved, consistency is there. You can control the output format and style. It can help you do nuanced task, right? So in few short, we provide examples. We are shaping. We can shape the tone of the output. We can shape the format of the output. Like I talked about the zero shot prompt by a marketing team. They gave a prompt, write an ad for a smartwatch. Now in few shot, you give two sample ads, right? So you say, I'm giving two sample ads. And then you say, now write one in a similar style for a Gen Z audience in India. Now this output for this prompt would be much more relevant. It will be much more specific, and it will be, something that will match the style of the marketing team, right? So here are a few examples. You know, when we say classify the sentiment as positive, negative, or neutral, right? So now you know that the model has three classes. You're not leaving the, you know, you're not at the mercy of the model to classify it the way it wants, right? Like a true or a false or a, by, it's not a binary classification. We know that it is multi-class, and the classes are positive, negative, and neutral. So, and we are telling this movie was absolutely terrible is negative. The restaurant's ambience was nice, but the food was mediocre is neutral, because there was a positive and negative, and both kind of canceling each other out becomes neutral. And we are saying, I love this new smartphone, it's fast and has a great camera, and that is a positive sentiment. Now we are telling classify the concert was okay, but the sound quality could have been better, right? So now it will probably do a better job of classifying this. Had we not given example, it might have given more importance to the first part of the sentence, which says concert was okay, and say it's positive. And it might have considered the quality could have been better is just an improvement that we are recommending, right? And the overall could be neutral or positive, right? So and it might say, because there is no neutral, it's usually a binary classifier. It might always say that these kind of sentences are positive sentiment. But now that we are telling I have three classes and I have examples of each. Now when it tries to classify, it will say that the output is neutral. Another example, right? So we are telling transform the following sentence into a more formal style. Hey, what's up? And that should sound like good day, how are you doing? That movie was awesome. And instead of that, the more formal style is the film was exceptionally enjoyable. Now, transform this sentence. I'm gonna grab some grub. Now, there are enough examples for the large language model, and the output would sound something like, I'm going to procure some sustenance, right? So it's much more formal style. So that's few shot prompting where you give few examples. Here in each case, I gave three examples. In this case, I gave two examples, right? So the more the examples you give, there is more better task specific, outcome accuracy that you can expect, right? There's another technique of prompting called chain of thought prompting. Here, we are encouraging the model to break down a complex task into sequence of steps where we are kind of simulating how human thinks. And this is particularly effective when you want multi-step reasoning. We look at some examples. Here you're actually asking AI to show how it actually works, and then you will try to improve the logic. And let's take an example. You're you're trying to ask what's the best way to reduce logistic cost by 20%. Without chain of thought, a generic response you would get, as use automation, negotiate contract, blah blah, right? Whereas with chain of thought, let's say, let's take this example, right? I know I've been throwing a lot of examples, folks. I hope you have been um, able to use them and appreciate them. So let's take this example, right? So we are talking about chain of thought prompting, right? A chain of thought is where you're asking AI to show its work and improve its logic, right? And a generic prompt could sound something like, what is the best way to reduce logistics by or logistics cost by 20%, right? So now this is a very generic prompt, and you could expect, blah blah blah. Of course, there will be some opening statement, and then the gist of it would be, let's say, to use automation, right? To negotiate contract with your suppliers, right? To your with your vendors, etc. Right? So very generic, right? Whereas if you were to use chain of thought, your prompt would sound something like this, right? Now you can write multiple ways. I would put it something like this. I will say list possible levers, right? Step by step, compare the cost, compare cost saving potential of each step, right? Compare the feasibility and also the risk, because that's important, and then recommend the best, right? See how we transformed a generic prompt into a more, uh, you know, um, where, where there is a structured option, right? Where now we can take better decision. We are not relying on the output of the prompt, right? It will recommend, but because there is a list, there's a possible comparison, there's a potential cost saving that it's showing, and the feasibility and the risk of each of these options, we can now take the decision, right? And we can see if LLM's recommendation is good enough, or is there anything else that we can look at, right? So it's all about reasoning, right? Chain of thought, is basically how would you use the reasoning of the large language model to be able to get the most of it, right? Another type of prompting technique is the roles and persona. Okay, so here you're basically telling act as a CFO, and now you will get more conservative, more numbers driven prompt. You're basically asking the LLM to perform differently based on the role you're assigning. You can say act as a motivational speaker. Now the output will be more persuasive, it will be more emotional, right? Now I'll give an example of a role prompt. Let's say CEO of a company wants a board ready summary of quarterly result. Let's take Q3 result. It was recently out. So Q3 results, the CEO wants a board ready summary, right? A prompt, a generic prompt could look like summarize Q3 results, and what you get will be dry numbers. Whereas if you prompt something like this, act as a McKinsey consultant and write a one-page board memo on Q3 result, highlight the key risk, highlight opportunities, and provide three action recommendations. Now, this kind of a prompt will give you executive level narrative, right? So you can again, tailor this for a customer support. You can tailor this as an educational tutor. You can tailor this as a creative, right? Right. Now, that's not all of it. There are other types of prompting as well. There is something called iterative refinement, where you treat AI as your conversational partner. And the very first prompt, you don't expect that as a final response, right? And you try to refine the response, from there, right? So you ask, make it shorter, make it punchier, make it, look good from a customer's point of view. Right. Let's say you want to do a sales pitch and you go ask LLM to give me a first draft, a two-page first draft. Now the first refinement cycle will begin where you will say, compress this draft so that it is adaptable for a CFO, and then adapt it for a CTO, because CFO would like to look at financial numbers. CTO might look like the technological, potential and technological aspect of of the pitch. And then you can also ask the LLM to refine for a LinkedIn post, right? Now you can basically turn one input into a multi-channel asset, right? So these are examples of iterative refinement, another technique, um, which you can also consider, right? So typically what we are telling is, you need not use one technique. You can use a combination of technique. For example, you can use the role technique along with few shot and chain of thought plus some iterative refinement. For example, you can say, as a data scientist, here are the input output pairs, right? You're giving some examples. Now walk through your reasoning. You're also doing chain of thought and then refine the answer based on feedback, right? So you're making it iterative. So you can also combine the strategy. That's what we are telling. And that will probably give you better results than when you do that in isolation, right? So iterative refinement, which is multi-step prompting we talked about, you don't consider the first outcome of the prompt as the final. It's just a draft, and use that draft to make it more shorter, punchier, from a different persona point of view, right? So those are some of the techniques. Here are a few examples. So here I'm giving a prompt, summarize this article, where probably an article, very naive, and the output is a generic summary of it. And most cases, these are vague. However, if you refine this in a way that you're saying you're an educational tech analyst, summarize this article in three bullet points, highlight the implications for upskilling, and suggest one next step action. Now you have a more sharper output, very targeted output, and some actionable summary which you can take away. Another example, write a marketing ad for our AI course. It's a generic ad copy, as you see. However, you can refine it as such, where we are saying you are a senior marketing strategist. Write a two-line ad for GenAI course targeting mid-level professionals in India, emphasizing career impact, emphasizing diversity of your organization, and things like that. Now you're more focused, you're more resonant. You have used, you have given context. You can also add few shots with some examples of previous, ad that you had placed, right? And if you're not happy, you can always do a iterative refinement, right? Now I can go on with the use case and what strategy would use, right? But I want to just pause here and talk about things like, you know, how would you scale this, right? Now, scaling this is very simple, similar to how we scaled automation. right? So earlier, whenever, long ago, if you all remember, we had Excels and some, formulas that leads to calculating certain values, and that was the kind of automation, right? Now, how did we scale that, right? So we had templates, right? We came up with RTIs, RFT templates, right? And those were stored, and then the entire organization started using that, right? And we were building APIs. If you are from software delivery, you might know that building APIs, each team builds on its own framework, own architecture, right? So we came up with a common framework. Libraries were published, and everyone started using that. Now there's a consistent way of building APIs. So very similar to that, prompt scaling, right? You would you can scale this using templates, right? So you can have prompt templates which can be used across your organization, and everyone uses the same template, and there is a like a center of excellence team or a prompt engineering team which is actually continuously refining and upgrading these templates, right? And of course, these are templates, these are only for reference. In most cases it can be used as is, but then if you have a very specific use case, you can always refine that for your use, right? Now, I would like to iterate here, prompt engineering is not the only way of getting task-specific outcome from a large language model. We definitely have supervised fine-tuning techniques like RAG, but those are expensive, and your first approach, your almost by default your approach to get the task specific or nuanced experience from a large language model should be using ChatGPT, should be using good prompts, right? Now I want to talk about a few more things, right, before we get into the real world applications, right? So we talked about how transformers, the LLM has different techniques like tokenizations, different techniques like embeddings, and then there's a transformer which is the heart of a large language model, right? And then we are doing something called pre-training, where we are training the model with lots of billions of parameters, right? And that's called a pre-training phase. And after pre-training, the large language model behaves as a general purpose model, right? Then we do something called inference. Inference is where we do prompting, right? We prompt and try to get the output from a large language model, right? So another technique is something I wanted to call out, right? So while we are in this discussion, so this technique is called RLHF, right? Reinforcement learning with a human feedback. So I wanted to just throw some light on this technique. So because it's very powerful, I know we could have got into the different parameters of large language model and prompts, but that can be a very long discussion. But let me talk about RLHF, right, which can be something you can take away. Like I said, RLHF means reinforcement learning with human feedback, right? So the raw LLMs, right, which are pre-trained LLMs, right, they're good at predicting the next word. And you're also giving good, careful prompts, so you're getting that. But the output, even after good prompts, they can be too long, they can be too short, they can be factually wrong, right? What we call as hallucination, right? They can be inappropriate, they can be unsafe, right? I was talking about an example where you want to give white glove service, right? So the outcome of output of LLM is now very casual, right? I want to keep it very formal, more classic styled, right? And it's not aligned with our expectations many times, even after good prompting. Like for example, you take a general purpose LLM, you want to prompt in a way that it tells how do I reset my bank password. No matter how good the prompts you give, your system has a very specific way of resetting the password. So it will give very generic. It will say, it will ramble about password history, and it will not give you a clear step, which is very specific to your banking application, right? But what RLHF does is it teaches the model to respond the way humans want. It's a three-step process, RLHF, right? So RLHF is a three-step process. The first step is it will collect human feedback. The second step is there is something called a reward model that is trained. Oops. Right. Hopefully you can still see my screen. My monitor kind of crashed. Um, so there is a reward model, right? And the third step is reinforcement learning. Now let me explain this with a quick image from the web, so it is more clear. And I hope you can still see my screen. Right. So this is a great illustration of RLHF, right? So I'll try to explain this very quick. And you have a base LLM, right? So this is the base LLM, which is pre-trained, which is trained on billions of parameters. Now you're trying to give the output of the base LLM. You're providing human demonstration data, how you expect the model should have actually responded, right? There is a response from the model, and there is let's say a target, or a better response that you expect, or expected response, right? And you provide both of them to a supervised fine tuning model, right? This is called SFT, supervised fine tuning model. So that is how you train this model. Now you take this model, right? So there is already this base LLM. You take this model, and now you start giving prompts, right? And now with the even after fine tuning, it's not still perfect. It can give multiple responses. So a human is there in the loop, who will rate which is the better response. It'll look at response one, response two, and look at response one is better than response two, right? A human is rating that. And again, this human's response is fed back into another model called reward model, where this reward model will take the place of a human in real time in production. And every time it does this rating correctly, it is rewarded. So the object of this model is to get rewarded as much as possible. And then let's say you have very organization specific policies. You bring in something called proximal policy optimizer, right? PPO, proximal policy optimizer. Anything, something you can again look up. Very, very popular approach when it comes to large language model and using base LLMs. So now with anything with any prompt comes, right? So you take this supervised fine tuning model, which is on top of base LLM, which is also on top of a reward model, right? There it is adding a policy. It is telling now this response, you need to make it more sound more formal. You need to sound it more technical, right? You need to sound it more casual, right? So the policy, there should not be any cuss words. There should not be these words in the list, right? So those kind of policies it applies. And then it comes to the reward model, and reward model says, okay, this is a better model, better response, and then this is an iterative process, right? So typically that is how you would use RLHF, right? Now with RLHF, again, you can get very better, much better um, outputs, right? So we're almost at the end of the session. Here's where I want to talk about great learning as one of the very reputed learning edtech company. And this great learning has the testimonial of having so many career transitions, and there's so many hiring partners associated, right? And you can see all the partnership that it has with leading universities, right? So this is the AIFL program Lakshana was talking about in the beginning of the session. So it's a 5-month intensive program where you start with, even without any coding background, even without any mathematics background or statistics background or probability background, you can enroll in this course. The only expectation is that you should be at a leadership position where you are responsible for taking some decisions, right? So here we start with, how do you understand data? right? So very basic, and we use low code, no code platforms like Nime to drive home the point, right? Using hands-on. And then we talk about neural networks, supervised learning, unsupervised learning, and then you transition into generative AI for natural language workflows, right? Where you have, project, you have case studies, and it's a 2 week intensive, course within the program. And then all these courses or programs that we talked about comes with experiential learning. You have a capstone towards the end of the course, each course, and you're able to demonstrate your learning, right? And this program is designed by the latest, by the greatest of the academic world, and you get to work on multiple domains, right? Web scraping, EDA, visualization, BFSI, you name it, right? So please take a screenshot of this. This is how you can get in touch, if you are interested, if you want to take this forward. And there is the link which Lakshana shared on the Zoom chat. So please use that to fill the feedback form, and it will also allow us to get back to you in case you want to, you're interested and you want to get more serious about learning AI. So with that, thank you so much, folks, for your time. Hopefully, this one hour session was useful and you had something to take away. Thank you. All the very best.